So welcome to the introduction to RStudio. This is part of the StatPREP grant. We are also, which is an NSF grant, we're part of the MAA, the ASA, and AMATIC. My name is Kathryn Kozak. I am one of the PIs on the StatPREP grant. I teach at Coconino Community College in Flagstaff, Arizona, and I happen to also be the president of AMATIC. Joe, would you like to introduce yourself?
Sure. I'm Joe Roith. I teach at St. Olaf College in Northfield, Minnesota. And I've been involved in the StatPREP grant for the last 6 years or so, since the beginning, as a regional hub leader. And I've been doing workshops the last few years as well, including some R workshops this summer.
Thank you very much. Oops, I thought I had a slide in there. So I will let you know we're going to put our slides on here. Let me stop for just 1 second. I'm sorry.
No, I'm sorry, Kate. I'm not sure why that didn't go through.
That's okay. It's okay. All right. So yeah, the recording, I still shared the wrong screen. All right, never mind. I just want to let you know we are recording this event. We retain the right to show it again and to distribute it. By participating, you are agreeing that you are contributing, that your contributions, text in the chat, and videos enabled, etc., part of the event recording. So I do want to make the comment, we are going to have some links here. Those are going to have some slides. We have our slides and our links so that you can get to them and access them later. If you are watching this recording, you may want to go ahead and note these down so you can get access to these slides. We will also be using some RStudio Cloud material, actually some RStudio, and this URL has some of our code and data that we'll be using. So again, you may want to note this down also. It's in the links to the slides, so you can also get it there. If you go into this document, it has some of the packages that we'll be using and some of the data sets we're using today you can get access to. The options for you doing RStudio, there are 3 different options. We have the RStudio Cloud, which is a free site that you can use. You can go into this, you can create your own RStudio Cloud. You can either, if you haven't signed up yet, you can sign up right now. If you have signed up, you can log into one. And you can create your own RStudio Cloud that way. The other options you can have is a desktop version that is also free to download. So you can go into this link here that gets you a way to download this into your RStudio Cloud, RStudio, so you can have this on your desktop. It does have to be either a Windows machine or a Mac machine that you would use on this. The third option is an RStudio Server. This is also depends on your school has to set this up. Your institution would have to set up an RStudio Server. If you're using this in your classes, this is also free to use. So it is there for you to use also if you're using it in your classes. So I just put in my syllabus that I'm using RStudio in my classes, and I can get my RStudio Server on my campus. If you would go into yours, mine, this is what mine looks like. What I want to do now is just kind of talk about what each one of these looks like and what the RStudio environment looks like. The RStudio environment has multiple panes. And what this works is this main one right here, where it says console, terminal, and jobs, has what we call our pane, is one of our panes. This is our main console. This is where a lot of the R commands are actually actually uses this to execute these commands. Another pane over here is this window that looks like it has environment, history, and connections. This also changes depending on what you have. You would have things in the environment which show you what data sets you've loaded into R. Another pane is the one that says files, plots, packages, help, and viewer. These are different files that you could load into here. This is actually my server that I use. So you can see I have lots of things in my server. I actually have a statistics class material. This is from my students, and anybody on my campus can access this. So there's different things you can use in here. I'm going to go ahead and go into my RStudio workshop folder, and this has other things that can load into here. If you are on, no matter whether you're on RStudio Cloud, RStudio Desktop, or RStudio Server, you can upload these. RStudio Desktop, you would just actually open the file. But in RStudio Cloud or RStudio Server, you would upload this file. You could then go into your computer. If you've downloaded the files from that website that we gave you, that link we gave you, you could then upload that one in. So you can then click on, I want to upload packages, say you want to open it, and it would then open that directly into your environment right here. I already have it there, so I'm going to go ahead and overload it. It's no big deal to overwrite it. And it now has that in here. It actually puts it at the bottom usually when it first brings it in. And then I can upload the other ones also. So those are kind of our different places we can do with this. If I were to go ahead and open up the packages one, which is the one I just uploaded, I get another pane that opens up. And it basically is over here where the console was. It's right above the console. And you can have multiple tabs here open. You can have your different RMD files. They're called R Markdown files. You can have loaded here. You can also, if you have data in your data set, you can actually open them up over here and look at that data set if you want to. If you want to make your own RMD file, I normally actually take an RMD file that already exists and then save it. So I would then go over here to File and I do Save As. I would then rename it and then save it wherever you want to in your, either on your cloud or in your desktop or in your workshop, and wherever you want to save it. I actually have all three. I have all three environments. I have a cloud, a server, and a desktop version. Then you would just name it how you'd like to. Just make sure it ends in RMD. So maybe I name this one test just to give it some name. And then what I like to do is I then say, oh, I don't need this for mine. So I can then delete all the things I don't need. So I would then keep this here. You want this part up here. This is known as the YAML. And this is where it basically has the title, who authored it, if you happen to have a subtitle on it, and what kind of output you want to use for it. And then you want some other things. You also want to keep your setup. This is known as an R chunk. You want to keep that setup there. So you could delete everything else. And that's an easy way to create a new one, is take an old one, delete everything you don't need, and then you have a fresh start to go with. So that's kind of how we go with the environment and what it looks like. You can also create a new document. You can actually come over here to File, go into New File, and say you want to create a new one. And it will also create a new one for you. Again, you can call it something else. I could call this one Test 2 if I wanted to. And then again, I would go and delete all the things I don't need out of it. It gives you kind of an idea of how things work, but I would delete a lot of the things that you don't need. Everything from setup on down, you would delete. It's always the best way to kind of get these and work with them. So that's normally what I do, is how do I create those? We also have some common errors that can happen when you're doing things in RStudio. The main common error is it's very case sensitive. So in fact, today in my classes, my students had to remind me that what I was typing was a lowercase and I needed an uppercase. So make sure you watch what your case is of the variable names and any of the commands you're doing. Another common mistake is you use the wrong command. You have quantitative data, but you try to do a bar graph with it, or you had qualitative data and you try to do a density plot. So watch what kind of command you're trying to do. Make sure you're doing the correct command. You also might have some wrong syntax in your command, so make sure you use the correct syntax when you type your commands. You'll see some of that syntax when Joe starts to show more information. Another mistake is you think you've uploaded your data set, but you actually didn't. And you're trying to use that data set, but it's not actually imported into your environment. So that's another mistake that can happen. So you want to make sure in your environment you see that data set is there. And a very common mistake is that you need to have what we call libraries, because we have different packages in RStudio, and you'll find out that you forgot to load the right package or the right library, basically. And so that's a very important thing you want to make sure you also do is that. In fact, I just had a colleague, her student was having trouble because he couldn't get something to work because he didn't load the right package. So those are some of the common mistakes and common errors we see. There are other ones you also see. We do have a document, and if you could put that in the chat for me, Grace. We have a document, and I'm going to show you where that document is. Now I've lost it. And it's just a question and answer document. If you want to put your questions in this document, a lot of times when we put them in here, it's nice for you to actually in your R command. So I go back over to my RStudio here. Oops. I go back over here to my RStudio. There I am. I can actually highlight anything I want, and I can copy it, and I can paste that into anywhere I want. So notice I grab some R chunks and other information. I also can see things down here when I run something. You'll see things in the console. A lot of times they'll give you error comments. Copy those and paste them into this question thing, and then we can look and see what the errors might look like and see if we can figure out what your error is happening, what's going on. You can also take screenshots of those errors. Those are also helpful. But if you just tell us you're getting an error, but we don't know where, it's very difficult to find out what those are. So now what we're going to do is Joe's going to actually show you some of how we work with some of the packages that we want to work with. So I'm going to stop sharing, and Joe will take over and show you some stuff.
All right. So give me 1 second to get set up here.
And so there is a question coming into that document. Things are not auto-saved, so you do need to save. That is one of the other big mistakes I see from my students is they forget to save the material and then they lose it. So do make sure that you do save things. Now, I say they're not auto-save, but there's a process you can go through called knitting, which we're not going to go into today. That will save when you hit knit, but otherwise they're not auto-saved.
Yes. And like Kate said, you know, being that this is a 1 hour webinar, we're not going to be able to troubleshoot through everybody's issues and errors, but we will try to, at least for the live version of this, we'll try to take a look at that questions document over the next day or so and try to respond with some of our answers to any issues or errors that you might be having. Because, you know, learning R can be frustrating at times, and you can get some errors that you don't really know what they're pointing to if you're new at this, but we will do our best to kind of help out, and hopefully the recording of this will allow you to kind of go back and figure out what you could do.
I also want to kind of real quickly just say that you can also, we have a community on MAA Connect, so you could also go onto there and post your questions on there. We'll also give our emails at the end. You can email us, and we can let you know if things are happening, and maybe we can figure out your errors.
Yes.
Okay.
All right. So one of the first things that we need to sort of understand when we work in R is the fact that since R is this free, open sourced statistical software, it's one of the biggest benefits and one of the biggest reasons why it is so popular just in academia and also, you know, in industry, is that anybody around the world can write their own functions, put together their own data sets, perform their own specialized tasks in R, and share that code with the larger community. And so what we want to do is we want to, you know, leverage the work that other people have done to make things in our life easier when we're working with R. But that means that we do need to sort of load and install these additional packages to use these types of functions or data sets in R. And so, like I said, it's could be some code that you find that is a little bit more graphically impressive than the base R graphics, or it could be a data set that you want to use. But typically, anytime we work in R, one of the first things that we do is sort of identify what packages we need to either install or just load. So in that shared folder with some of our code, I'm going to be looking at the one_packages file. So again, to give you a, to get back into our RStudio workspace, once I open up my packages RMD, I get this fourth window that pops up. And I can start treating this like a notebook, basically. And in my notebook, I have two sections. I've got a section for just text, where I just can write down my thoughts. I can write down homework assignment questions, whatever it might be. That's just kind of in the regular white background. And then I have R chunks, which are in this darker gray shade. And these R chunks are kind of what make these RMD files, these R markdown files, so useful to us, because we can run our code and write our code in the same place, and we can edit and we can comment on things. But basically, these R chunks are the workhorse for letting R do our statistical analysis or just basic computing. So you can see in this chunk, I just have some basic math statements, algebraic statements. And if I click on this run current chunk kind of play button here, that will run everything, all the R code in this chunk. And notice that it does run, these two lines here, but it doesn't run anything that is kind of behind this hashtag #. These are what we call comments to kind of describe our code a little bit. The other option, which you'll see me do a lot throughout this webinar, is rather than run every piece of code in this chunk, that's what will happen when I run the play button. If I want to run a single line at a time, I can just place my cursor on that line and press Control Enter or Command Return if you're on a Mac, and it will just run one line at a time. So I can run those individually. All right. So just a little bit more, orientation to the environment. But like I said, packages in R are really going to be the workhorse for, getting more efficient code, better functions, more helpful functions that the basic program may not have. And anytime that you first use a package or want to use a package in R, you do have to install that package. So if this is your first time using R, if you've got it open, if you just downloaded it and installed it, we're going to be using the Mosaic and GG formula package today. If you've never used those before, then you will most likely need to run a line like this to install those packages. But the nice thing is, once you do that, you won't have to install that again. So once it's installed, it's pretty much always there. Now, if you're on RStudio Cloud, you may have to install this for each project that you run, because the cloud server is going to kind of reset for every new project. But really, you should only need to do this once for a project, or once, when you download desktop, or if you have your server on your campus. So I'm not going to run these because I actually already have them installed. But I do need to make sure that at the beginning of my document, I have loaded those libraries. So installing these libraries doesn't ensure that we get to use the data sets or the functions within these packages. For every RMD file, or for every time I open up RStudio and I want to use those functions in those packages, I need to make sure that I have sort of the setup R chunk where I'm loading each of the individual libraries that I want to use. So library Mosaic, library GG formula, and there's one extra one, library read R, that will help us read in data. Like I said, Mosaic and GG formula, these just have a lot of the functions that I'll show you in a little bit to do some of our basic summary statistics and plotting in kind of a nice way. And oftentimes I get the question, I don't know what package I'll need. I don't know the formula or the function that I'll be using for a particular task. And that's true of all of us, right? We don't really know the packages until we search for, how do I do this in R? And oftentimes it's just kind of through the R community that you find out that oh, this particular package will allow me to make a cool 3D, visualization, or whatever it is you might be doing. All right. So then, another thing that we need to be able to do as we're sort of setting up our R environment to start working in it is we need to be able to access and connect to data, right? So an important aspect of this is either importing or accessing data. And I'm basically gonna talk about three of the, I would think, the most common ways of accessing, connecting to a data source in RStudio. And that's either directly from a package, from some CSV file, or Excel file that you have locally or in your workspace, and then accessing data from a URL. So I'm going to jump back to my RStudio. And like I said, there's the first way of, and maybe the simplest way of accessing data is to look at data that just belongs directly in a package, like our Mosaic package. It contains several really nice data sets that we can sort of use to teach a class or illustrate a certain function or plot. So if that's the case, that you're looking for a data set from a package, you just first need to load the package. Again, it's not going to hurt, but I don't need to run this again since I already loaded Mosaic. But load the library, and then just run this data parentheses your data set name, basically. So I'm just using the births data set that I happen to know lives in the Mosaic package, and in these quotations as well. And you can see when I ran that in my environment, this births value showed up. And it shows promise right now because I haven't actually asked R to do anything with the births data set. But if I click on this, it'll let me know, okay, births is 7,305 observations of 8 variables, and now it's ready to be used. Another way, right, to import your data is from a local CSV file. Again, either something that you've downloaded to your personal machine, or something that is locally, as far as in your maybe your RStudio Cloud folder. The data set that we're going to be using today is called sleepstudy.csv. And so if I'm doing something like this, I'm going to write a line of code that does a few things. First, it names the data set, right? And we always want to name data sets in R so that we can refer to them later. So I can call different variables data. Then I'm going to use this assignment syntax, this less than dash. It looks like an arrow. That basically just says, okay, I want to assign to the name sleep this CSV file. And we take advantage of the read_CSV function, where all we need to do is just sort of locate the file path for the data set and put that file path in that in between those quotations. And I'll let you know a shortcut if you have this data set in your folder, or if you want to upload it to your folder, you can click upload, and then kind of just choose a file from your desktop, from your downloads folder, wherever it might be. But if you have it in this folder, you can click on it and click on import data set. And down in this, well, first of all, it'll give you a nice little preview, right, of your data. And down in this lower right-hand corner, it will actually give you a nice little shortcut for that file location to read the data set in. Okay. And then the third option, reading from a website, looks actually a lot like the second option, where I have named my data set sleep. I'm using the assignment syntax. and I'm using the read_CSV function, but now my file location, I can just use a basic URL. So I have this data set on my GitHub account that is available to the public for anybody to access. And so this is the one that I will be using, and you should all be able to use fairly easily. I find that reading data in this format is a lot better for teaching class, since all my students are going to have different file paths on their own machines or in wherever they're using RStudio. Whereas if I just have the data set on my GitHub account, then I can provide them with one URL, and this one piece of code will sort of serve the purpose for everybody. All right. So that sort of sets us up to talk about some basic tasks that we would want to do with our data set in R. So I'm going to jump back here, and I'm going to talk a little bit about exploratory data analysis. And so this is one of the very first things, right, that I like to talk about in my classes, in my introductory statistics classes. I want to build this curiosity in my students. I want to build these skills and tools in my students for them to ask questions about data, and to also be able to probe the data and look around and develop questions based off of what they, just playing around with the data. And so we call that exploratory data analysis. And again, I sort of break this down into two different approaches for exploratory data analysis. Right? What do we do when we want to summarize or visualize a numeric variable? And what do we do when we want to summarize or visualize a categorical variable? Right. So I'm gonna open up our second RMD file, 2_EDA, and we're gonna get some practice with both of these, as well as get some practice with visualizing these types of data. So back into RStudio, go back up to the top here. All right. So again, I don't necessarily need to do this, but it's good practice for every new RMD file, R Markdown file that you have. You can reload the packages that you'll need in this setup chunk, your very first chunk, and you can also reload the data set. So I know that if somebody were to open this up independently, they'd be able to just get going from the start. So I will rerun this just to make sure everything's there. And just real basic, I want to be able to look at the data set, right? If you have students, or if you're more familiar with like an Excel style data program, then you notice that you can't really see the data set here. But if I use this view function and refer to my data set, it will sort of allow me to look at my data set in spreadsheet format. But more importantly, and this is a key distinction from Excel, I can't go in and edit any of these things, which is a good thing, right? I don't really want to be able to have such easily edited data, because I don't want to accidentally change anything or alter my data in a way that I can't reverse it, or I don't know what the original version was. So you can change it within R, but I don't know if we'll get to that today. Other aspects about this data that I might be interested in is, what are the dimensions, right? So I would use maybe dim for sleep to see that I have 253 rows, 27 columns in my data set. And by the way, I will mention, absolutely at no point should you ever be expected to memorize these functions, this syntax. This is something that comes with practice, that comes with doing this over and over again. And by all means, use this code that we've shared with you as a template, right? If you read in a different data set, call it something else, you should be able to just swap out data set names or variable names and get the same functionality. So that gives me a little bit, I get to see the data, I get an idea of the shape of the data. But if I want to do a little bit more, actually, let me show you one more that I don't have on here. If I want to look at the column names, so the variables, oftentimes this is an important piece to have. I can use names of sleep. This is important because this will tell me the names of each of the columns, and more importantly, it'll give me the spelling and the case usage for each of the variables, because as Kate mentioned, R is case sensitive. So if I try to use gender with a lowercase g, R is not going to know what that is. It only recognizes gender with a capital G, right? Because that's how it's spelled in the data set. But so I like I said, I'm going to go through some different ways of summarizing, basic summarization of the data. And I do just want to take a second to point out the fact that, well, in this short 1 hour webinar, we're going to throw a lot of things at you. But I want you to notice sort of some of the consistencies between our different pieces of code. And one of the things that you'll notice is that anytime I want to do something in R with my data, I'm asking R to execute some sort of function, right? So the function is always going to be descriptive, or should at least usually is descriptive of what my goal is, right? And it's going to be followed by these parentheses with arguments that the function requires in order to execute. So you'll see, function, and then in a lot of these cases, we're going to be using formula notation when we're dealing with variables, which includes use of the tilde, which I would ask, take a second on your keyboard to locate the tilde. Usually it's in the upper left-hand corner, right above tab, next to 1. Because this is sort of important for us to be able to identify the different roles that our variables play when we're looking at different types of summaries or plots. So notice that a lot of the functions that we use will all sort of follow this syntax, where we use the formula notation as the first argument, we define the data set, and then depending on what function we're using, we might have some additional arguments to specify different features. So let's go ahead and jump right in. And if we're talking about getting some basic summary statistics about a numeric variable, like GPA in our data set, the function that we'll be using from the Mosaic package is df_stats. And again, you'll notice the tilde notation, formula notation, with GPA to the right of the tilde. And then a second argument, we specify the data set. So running this df stats for GPA from the data set sleep, I get kind of these common summary statistics for that variable, right? So I get my 5-number summary, I get the mean, I get standard deviation, sample size, and how many are missing. I can also just ask for a single summary statistic using df stats. And this is sort of an example of using an additional argument where I have the same initial information, but one more argument where I say, well, just give me the mean. I don't need all this other stuff. And that works just as well to tell me that, okay, the average GPA in this data set was 3.24. So I guess I didn't mention, so this data set, this comes from a survey of 253 liberal arts students from a college in the Northeast, I believe, just on their sleep habits, study habits, things like that.
Joe, you might mention how do you do just one line of code in the R chunk?
Yes, so if I want to run just one line, as long as my cursor is on that line, then I just hit Control and Enter at the same time, and it will run one line at a time, or Command Return if you're on a Mac. So if I wanted to, find the standard deviation for the drinks variable, right? I could say dfstats tilde drinks from the data sets, sleep, and just ask for the standard deviation. 4.09. And I think I'll talk about this a little bit later, but it's probably just as good to talk about it now. There are certain arguments that you may not know, which arguments you can add to a specific function. But as long as if you know the function that you're using, you can always look at the help documentation by putting a question mark in front of that function name and running it. And in this case, it gives us a couple different options for the df stats. We're using Mosaic, so this will tell us all about description, how to use it, and I believe it may even give you a list of different. Maybe this one doesn't, but I give you some examples at least of different additional arguments that you can have, like the mean, the median, the range. So it's always a nice feature to kind of look into the help documentation if you're not quite sure how to use a function. At the very least, they should have some examples. Okay, but let's keep moving, and let's make things a little bit more interesting by adding other variables, right? I think that's where the magic happens in statistics, is looking at relationships between variables. So if we add a categorical variable to GPA and start looking at breaking down GPA by different chronotypes. So there was a variable that recorded whether students were a night owl, a morning lark, or neither. And let's break down our GPA by those groups. Still using the df stats, but now we kind of have this response and explanatory relationship. So notice that GPA, our response variable, the one that we're sort of interested in the outcome, measuring that outcome, jumps to the left of the tilde, and our explanatory groups goes on the right. Lark, owl is that chronotype variable name. So running this, I can see now I get 3 lines in my output, and they're all GPA, but now they're GPA for the 3 different groups. And I can see, oh, morning larks have a slightly higher GPA than those who didn't identify as either, and even a little bit higher than those who identified as a night owl. And you could add more, right? You could add more categorical variables, more groupings. There's a stress variable. I believe it's either high stress or normal. But I can add 2 categorical groups and break down my table even further. I just kind of have to pay attention to the different combinations of lark, owl, and stress to compare those different groups. Okay. So let's, again, kind of keep going. I want to make sure that we get through as much as we can here. That's how we would maybe look at a numeric variable and a numeric and categorical variable. What about just categorical variables, getting counts, right? Getting proportions. In this case, there are lots of options again, but the one function that I like to use is the tally function. Using it in a similar way as before, where I'm using formula notation, and this time alcohol use is to the right of the tilde. And since alcohol use is this categorical variable. R is just going to count things up, tally things up, and put them in a nice little table. So I can see how many I have for each group. If I prefer proportions, then I can add the additional argument format equals proportion, and that will give me the proportion of the total. Again, if you're not sure how this works, you can always look at the help documentation for some examples, and for other options for format. I could have done a percent, I could have done a count, and then these are some other more technical ways of getting the format. If we again try to complicate things a little bit by adding additional variables, I go back to this formula syntax with my response variable on the left of the tilde, explanatory on the right. So if I want to see alcohol use by lark owl chronotype, then I can get this two-way table. In this case, I am asking for a table of proportions. I added some margins, right? And I will point out that because of how I defined this relationship, I'm actually given a conditional probability. So you'll notice that the columns in each of these columns in my output all add up to 1. So these are proportional. These are proportions conditional on lark owl. So this is 14% who abstain given they're a morning lark. And I'll let you, if you have some time later, to play around with switching the order of these, right, to get different conditional probabilities. Or trying this out, putting the tilde and then putting both alcohol use and lark owl to the right of the tilde to get just overall joint probabilities as well. But I'll kind of leave that to you as homework to try out.
Joe, this question was asked in the chat, and not the chat, but in the document. I was answering it for everybody, for the one person. I want to make sure everybody else knows this. R ignores spaces. And so you'll see Joe uses a lot of spaces to make it more readable for the person, for him and anybody else looking at to read it. But we don't need the spaces in there. They're not needed at all, but it just makes life so much harder when the spaces aren't there.
Yes, thank you, Kate. R will ignore white space. It will ignore new lines for the most part if it's within a function. So if I put format on a new line just to kind of align things a little bit better, it will run it the exact same way. Yes. All right. There are some syntax guides. I'll give you a link at the end today to lots of resources, and I think one of those is a syntax guide for kind of the most common used style of writing in R, writing code. All right, so I've got to, let me see, I got to pick things up a little bit. Let's talk about, the other type of exploratory data analysis that we may want to perform is visualizing data, right? So we can summarize numerically with statistics or with tables, and now we want to visualize. And within the Mosaic package, a lot of the visualization is very straightforward, at least the functions are very descriptive, for density plots, for bar plots, for bar plots. They all sort of start with GF and have an underscore and then whatever it is we want to do. So let's go through some of these examples. Again, I'll go back to one numeric variable. And hopefully what you'll notice is that while the function changed, GF underscore density, the basic argument structure has not. In fact, this is the exact same argument inside the parentheses that we used for DF stats when we're looking at GF density. And this will give me a nice little density plot of GPA. Get an idea of the, the distribution, the spread, the center, those kinds of things. Now, we do have the option to change and customize some of this. So we can change the color, the fill, the transparency of the plot. If I change the color to red, notice that for a plot like a density plot, all that does is change the outline. So in a lot of different plots, if you want to change the color, I think most people want to change the interior color. That would be the fill. So if I wanted to change the main color, I would change the fill. And then if I, again, want to kind of implement Lark Owl into this and get a sense of the different distributions of GPA based on their, their chronotype. Again, different options. So I can use this vertical bar and sort of keep GPA to the right of the tilde, and then group by Lark Owl. So what this does is this creates faceted windows, kind of splits each chronotype into their own density plot, which is maybe what you would like to do. Another option would be to maybe use color to your advantage and keep a single density plot, but change the color of your fill based on the different categorical levels of Lark Owl. And so for this one, for this approach, I'll just, another hint or tip, anytime you want to use change some sort of aesthetics about the plot, like the color or the size of a point or the shape of a point, and you want to use a variable to define, different colors or different shapes, then you do need to add a tilde in front of that variable name, for fill or for shape or for color. All right. And again, I might skip this for right now. I can always put some keys into these files and update them in that folder that we shared with you earlier. But I want to show you some of the other options here. Box plots, violin plots are another nice way to look at a numerical variable by groups. So in this case, we're going back to the response tilde explanatory. And in this case, when we're visualizing things, the side of the tilde that the variable on will correspond to the X or Y axis. So notice that Lark Owl is on the Y axis, GPA is on the X axis for this particular box plot. If I do a violin plot, but swap my variables, then that's a nice way to flip the coordinates, look at them vertically. I can look at a scatter plot, basically. Even though this is a categorical variable, this function will automatically identify lark, neither, and owl as individual points on the x-axis. So I can look at these as points. But I might want to consider jittering those points. And if you're not familiar with jittering is just a way to give a little nudge to each of my points, left or right, or up or down, to spread things out. Because it's a lot easier to detect overlapping, repetitive values, GPAs for different observations once I've jittered them than if I'm looking at them, right on top of each other. It's kind of hard to tell that there's a lot of neithers, green dots right at 3.0 GPA. It's a little bit easier to tell when I jitter it. To go back to categorical variables, again, if I want to look at just a bar plot, right, I can use sort of the same input arguments as I did for tally. I'm just kind of making this a little bit nicer to look at by giving it a color, dark green. If I want to look at proportions, right, GF props, and notice really the only thing that changes is the scale. And there's a question, could you overlay different plots? You can in R, not so much with these functions, but once you get into some more advanced types of plotting with like ggplot, then you have more ability to add multiple plots to the same page, if you will. And I just threw this in here because, you know, it bugs me. I don't know how many other people it bugs that my alcohol use categories are not really in order. So this is just an example of how you could reorder those. Not that it's crucial, but you know, I have to mention it. Again, trying to add more dimensionality to this, to add more variables. We have different options, right? You have lots of different options when you're trying to visualize things. You can use this vertical bar again to split your graphs into different facets, different windows. So I could get a bar plot for each of my chronotypes. I could stack my counts, right, based off of the color. So I'm just plotting alcohol use, but I'm changing the color by lark owl. I could do a conditional stacked. So this is where each of the bars goes up to 1. So I can get a better idea of the proportion in each of my alcohol use groups of chronotype. Or I could do a dodged or side by side. And so you can see, you can again play around with the different types of positions, the different pieces that are changing these plots. But I think that these are kind of four of the most common types of bar plots that you would maybe want to use. And then I think the last thing that I'll sort of leave you with before we open it up for a brief question and answer is some more, you know, customization, adding more variables. You know, you're not limited to just sort of these 2 or even 3 variable plots. You know, you're not limited to just using 2 numeric variables. You can add categorical variables by changing color, by changing size, shape. You can add titles with some of these additional arguments that you might have in your data set. So if I sort of take the last couple of minutes here to talk about one version that we haven't discussed yet, and that would be 2 numeric variables. First off, how do I summarize those? Well, I could get a correlation, again, using my formula notation. And maybe I'm interested in anxiety score and stress score to see how correlated those are in this among these students. And they're, you know, moderately to strongly correlated here, 0.698. If I want to plot those, again, anxiety being to the left of the tilde will be my y-axis, stress score will be on the x. I can add a title, scatter plot of anxiety versus stress. If I wanted to add other dimensions to this, you know, I could start adding things like color for lark owl, and let's do one more, shape, and let's see, I have to. What is it? Class year, that's what it is. Let's do a different shape for each class year. Oh, I know why. This is what happens when you do things on the fly, because class year is numeric. Actually, let's do stress. There we go. So now I have different colors for my lark, neither, and owl, and I've got different shapes for my stress, high, normal, and I may not be able to tell anything from this, but at least I've got a nice example of how to implement some more variables. So I'll make sure that I save this and update it in our shared folder. But at the very end here, I have got just a little bit of review for some of the functions that we've used. Again, there's definitely way more functionality and way more that you can do with R than what we've been able to cover in this 1 hour webinar. But I just sort of encourage you to try things out, to use this in your own classes, in your own work, a little bit at a time. Copy and paste. Don't feel like you need to write code from scratch. Yeah. So I'll just share this before we open it up to questions, but I do have a link here for some other resources, textbooks, online, cheat sheets and guides, and lots of different things for helping you continue our education.
So that was actually really good. That was a question that was just asked about that, as where to get more resources. I will also say another great resource is I Google. I just sit there and say, how do I do this in RStudio? And I Google it, and there is somebody out there who has done it and can tell you how to do it.
Yep.
And I taught myself how to use RStudio pretty much. I'm learning new things all the time, but I learned it from there by just Googling, I need to do this, and somebody's done it.
Yeah. So we do have a couple minutes for questions. Like I said, I don't know how much we can answer. I know a lot of times when we do these, the questions are more technical. But I don't know, Kate, was there anything in the question document that you saw that sort of came up a lot?
No, I've been answering all those questions, and they've been pretty much about where to find the stuff. And so as a reminder, the commands for how to do things in RStudio, what we use for the R Markdown files are in this document that we just shared with you, and we've shared that in the document also, so that you can find those and get those. Otherwise, there hasn't been very much. There's one question coming up. You do need to use Mosaic for using GG anything, the GG functions, the DF functions. And they're kind of certain commands need certain packages, as Joe was saying. So I have a package I use for creating a histogram for a discrete distribution. That needs a different package than what I'm using otherwise. So each one has certain ones, but any of the GF or DFs are in Mosaic. And that's actually my favorite package. Joe always talks about using other ones, but I find a lot of the things I want to do are in Mosaic. They basically taken a lot of the really good packages out there and kind of morphed them into Mosaic. And so I find that one, the one I use pretty much for all my students, and they can figure it out when I use that one. Yeah,
definitely. I mean, I will echo that. There are more than one way to do anything that you want to do in R. There's complicated ways, there's complex ways. The authors of the Mosaic package have been really intentional about trying to do things in a single line or single function, and to do things with consistent syntax, consistent formats, which is what makes Mosaic, in my opinion as well, a really good package to use in an introductory stats class. So your students are just kind of learning one way of doing things, and then just plugging in different functions or different variable names as they need.
So as also a reminder, we will be watching this document throughout the day. So if you're playing around with it and you want to see how to do something, find out you have a problem, go ahead and paste whatever you're trying, and we can look and see if we can give you an answer. We may not answer till tomorrow, but we will try to answer it. After tomorrow, we probably won't be letting you post it anymore, but you can certainly post things. You can email us, you can post things in the MAA Connect document and different things like that. Advice on using some of all Excel, Python, R into an intro stats course. So I actually teach an intro stats course. I actually do not use Excel at all. I can't stand Excel, and I can't figure out how to make a title on a graph. And if I can't tell my students how to make it easily, I don't want to do it. Whereas in R, I can just tell them, you type title equals, and you say what the title is going to be. I give my students the exact commands they need to use in my intro stats course. So they're not trying to play around with them or trying to figure things out. I even on a test would tell my students, tell me what you want to do, and I will tell you exactly how to command it. And so my students, most of them feel pretty good about things, and it's with any syntax, they've got to learn it. When I was using graphing calculators, they had to learn that, and they had a hard time with that one. How many classes with R do your student colleges offers every semester? We offer 4 courses of stats every semester, and each one of them is required to use R somewhere in there. I use some other packages along with that. I use, well, StatPREP has some things also. But that's what I do. And then one semester when I first learned R, I taught every single one of them so I could implement them all in the same way. So,
yeah.
Any other questions?
And just to go back, I would say as far as choosing between Excel, Python, R, as long as you make it, as long as you pick one, I think that providing too many options is just where you get in trouble. And maybe 2, if you want to do like Excel, if that's really what you want to use, or the textbook, if you want to use StatCrunch or something like that, you can use that. That's fine. But I would play around with trying R once or twice throughout the semester, not for points, not worth anything, but just to show your students, hey, this is how you do it in some other format.
There was another question that was asked. We have a StatPREP.org website, and I'll actually type it right now for you. Or maybe somebody else, maybe Grace can type it for us, because I'm trying to talk and type at the same time, and I don't do a very good job of that one. StatPREP.org has all of our website information, and I will be posting the recording to this on that StatPREP.org. It'll be under webinars. You'll see like one of the last little tabs at the top, I think says other resources, and under that you'll see where it says webinars, and they'll be posting this recording there, probably tomorrow or the next day.
All right. Well, thank you everybody for taking this step towards learning R. It's definitely you can't learn R in an hour, right. But you can get started. So we appreciate such great attendance, and hopefully this was helpful for you. I
hope so. And realize that you just try something. You can't break R. Nope. So just try something and see what happens and see where it goes from there. And somebody out there can help you. So like I said, there's always people out there that will help you and give you advice. Thank you all for coming.